Hi, I'm Ihong.
Hi, I'm Jiao.
We're Group K.
Today we are going to present the result of the Advanced Energy Vehicle project.
This video will explain the general design process and the steps we took to achieve our goals. The Advanced Energy Vehicle, AEV, is based on George Benny's railplane idea in the 1930s. It was a form of rail transport that ran on a running rail above and a guiding rail below with propellers in front, and was first designed to separate faster passenger traffic from freight ones down below. Unfortunately, being unable to secure the necessary funding, the company went bankrupt in 1937. The AEV project utilizes this concept to transfer along a track and retrieve a package that is on the other end. This has to be done while being as energy efficient as possible.
Both the team members decided to put the propeller on both sides of the AEV. This will make the AEV become more efficient. Both of the two designs put the Arduino under the base and the battery above the base. The difference is that Yihong's design was to use the T-base. Jiaolong's design was to use the rectangular base. The problem of the design was that the swing arm affected balance. The team tried to put it in different positions to balance the AEV. Finally, the team found the best location to balance the AEV. After that, the team was concerned with the balancing of the AEV after its initial run. Hence, the team came up with two new designs with different bases to be compared.
To compare the two final designs of the AEV, the team proceeded with the concept screening and scoring matrices. Based on the results, Final Design 1 scored better than that of Final Design 2, but due to the closeness of their scoring, the team decided to run tests on both the designs. They were run on a track with the same code, and their efficiencies were compared. Final Design 2 did better quantitatively compared to that of Final Design 1. However, it was only a mere 2 joules difference. In the end, Final Design 1 was chosen due to its better aerodynamics and aesthetics. It was also chosen because it uses less material compared to the other, although both the designs have the same price. The team decided to use only the components given by the university, as it saves cost and weight, as it only uses parts that were necessary. As mentioned earlier, the AEV is supposed to run from one end of the track to the other and retrieve a package. This has to be done by going through a series of obstacles. First, the AEV has to stop at the first pit stop for 7 seconds until the gate is opened before proceeding. After retrieving the package, the AEV has to wait another 7 seconds before returning to pit stop 1, with another 7 seconds wait, and continue back to the starting position. During the test, the team encountered inconsistencies with the AEV performance. The team believed it to be the depletion of the charge in the battery, and has opted to change the battery after every 2 to 3 runs to counteract this problem. Overall, the AEV used only 150 joules of energy for the whole track and weighs only 258 grams. This was much more efficient than the team had expected, as the preliminary runs around a quarter of a track used an average of 37 joules per run, which led the team to anticipate around 170 plus minus 15 joules of energy. The team also learned the importance of teamwork and time management throughout the project, as the team only had 2 members to work with throughout the semester. It taught us communications between team members as an important factor to prevent unnecessary work and miscommunications. The team's hard work and determination show that it is possible to take a concept and make it into a reality.
This project has taught us the importance of the design and planning process that will prove to be most valuable to us in the future. With this knowledge and skills gained, the team is confident that we will be able to overcome any obstacle that we may face in our future endeavors.
I'm Yihong.
I'm Jiaolong,
This is Group K.
signing off.